I'm Anil Kumar. Welcome to my series on previous test papers. I've taken up a test paper of an IB student, calculus. Let me share with you question number 2 and its solution now with you. We'll discuss how to find asymptotes of a rational function. Here is a copy of the same question. State all asymptotes for the following functions. We'll discuss two functions. First is f of x equals to 4 minus 2x squared divided by x squared minus 5x plus 6. The other one is f of x equals to x cubed plus x divided by x squared minus 1. So let's look into the function f of x equals to 4 minus 2x squared over x squared minus 5x plus 6. Let me rewrite this with minus 2x squared first, right? Over x squared minus 5x plus 6. Now, some of you could directly write down the answer. Since the degree of numerator and denominator is the same, we know that the horizontal asymptote exists, and the horizontal asymptote is y equals to ratio of these two, right, which is minus 2 over 1 or minus 2. Perfect. So that is how you find the horizontal asymptote. We'll actually also use the concept of limits to show how to find this out, since it is a part of calculus, right? So let's look into now concepts of limits. So when we talk about horizontal asymptote, we are seeing what happens when x approaches negative infinity and when x approaches positive infinity. So if the value of y approaches a value L, then y equals to L is horizontal asymptote. So that is the concept, correct? So let's move forward with this particular concept. So let's find the limit of our function when x approaches, let's say, positive infinity. The function here is minus 2x squared plus 4 over all this, right? So let me rewrite this. Minus 2x squared plus 4 over x squared minus 5x plus 6. Now to find this limit, what we can do is we can factor out 2x squared, or let's say just x squared. Better still, I'll factor minus 2x squared out so that I get the first term as 1, and dividing by 2 I get minus 2 over x squared. Is it clear to you? Divide by denominator, I'll factor x squared, so I get 1 minus 5 over x plus 6 over x squared. Correct? We need to find limit of this function. Let me write limit when x approaches positive infinity. Now, using the properties of limit, it is limit of each individual, right? So x squared cancels out. So we could write this as limit of each individual, right? So we now here have minus 2, right? So this is minus 2 times 1. And then when you do this, we write plus limit of 2 over x squared. And these limits are for x approaching positive infinity, correct? So I'm using properties of limit to rewrite the whole thing. Similarly, the denominator could be written as limit x approaches infinity for 1 minus limit x approaches infinity for 5 over x plus limit x approaches infinity for 6 over x squared, correct? This is a constant, so it will remain as minus 2. Now here, x is in the denominator, so that approaches 0. So we have plus 0 here. In the denominator, limit of a constant remains at 1, and these two limits will be 0, correct? So we clearly get minus 2. So y value approaches minus 2, and therefore we have a horizontal asymptote, which is y equals to minus 2. Is that clear? So that is how you get your solution. Perfect. Now let's look into the vertical asymptote. So when we talk about vertical asymptote, we'll factor and then see what are zeros for the denominator, right? So we have denominator, which is x squared minus 5x plus 6 plus 6 equals to 0. So if I factor this, what do I get? I get 3 times 2 is 6, which is also minus 5 when I take both negative, right? So I could write this as x minus 5 times x minus 2, correct, equals to 0. So the denominator is 0 for 5 and 2. And therefore, we get our vertical asymptote at x equals to 5 and at x equals to 2. Is that clear? So these are the two vertical asymptotes for part A. So I hope the concepts are clear. Now let's take part B. Here, the degree of numerator is 1 higher, and therefore, in this particular case, we expect oblique asymptote. Perfect. I'd like you to pause the video, answer this question, and then look into my suggestions. Now let us see how to find the asymptotes for the rational function f of x equals to x cubed plus x divided by x squared minus 1. Now since the degree is 1 higher, we expect oblique asymptote, right? To find the equation, we'll do long division. So let's divide and figure it out. So we'll divide x cubed. Now we'll fill it with the missing things, which is 0x squared plus x, and a constant we don't have. I'm just filling in 0 for that. Divisor is x squared plus 0x minus 1. So we get divide the given expression by x squared minus 1. It's important to write the placeholders. It helps. So we could multiply by x, getting us x cubed plus 0x squared minus x. When you take away, we get 2x plus 0, of course. So we don't need to divide it further. Now, once you get this situation, we could write the function f of x as equal to x plus the remainder 2x divided by x squared minus 1, right? So from here, you get the equation of oblique asymptote, which is y equals to x, right? This is oblique asymptote. So we get oblique asymptote whose equation is y equals to x. That is, the function is approaching this oblique asymptote, correct? What we're trying to say here is that if you try to sketch this graph, then the oblique asymptote will be y equals to x. Function is going to be a bit positive, plus something, right? So it is going to approach this as x approaches infinity from top, kind of like this. Do you understand this part? Correct? If I take a negative value, this becomes negative. So it is going to be lower than y equals to x. So it is going to approach from the lower side, this asymptote, which is y equals to x. So that is the oblique asymptote, y equals to x. So I hope the concept is clear, right? So let's move on and find the vertical asymptotes. So for vertical asymptote, I can equate denominator to 0. So let's find vertical asymptote now. That means denominator equals to 0. So we have x squared minus 1, which could be factored and written as, so this implies x squared minus 1 equals to 0, which implies x is equal to square root of plus minus 1 or plus minus 1, right? So we have two vertical asymptotes. One is x equals to 1, the other one is x equals to minus 1. So these are two vertical asymptotes, correct? So on a graph, they will be sketched kind of like this. So these are the two vertical asymptote, x equals to 1 and x equals to minus 1, correct? Now, it is important to note that there is no whole here, perfect? Since in the numerator, there is no factor with x plus minus 1. So I hope that makes sense. So I hope that helps you to understand how to find asymptotes for a rational function. Feel free to write your comments and share your views. And if you like and subscribe to my videos, that'd be great. Thanks for watching and all the best.